Okay, so I'm going to teach you guys a few techniques for how to do this, and then we're going to do these, and they're so fun. I know I'm sounding like a nerd, but okay. So if you're asked to simplify something here, well, you're like, well, it's already simplified. Well, we can actually make it a little bit cleaner, kind of, not really, but I'm going to teach you guys how to kind of change the looks of these around, and then that's going to help us once we get into problems where we're actually doing trig identities. So for example here, if they're asked to change this around, what we're going to do is we're going to multiply by what they said is a well-chosen one. So in this case, we're going to do conjugates. So when we multiply this by a conjugate, if you're probably wondering why the heck am I doing this right now, it's just to get us set up for some future problems that we're going to do where we actually have to prove that one side of an equation equals another. And I want you guys to be able to see what happens when we multiply by conjugates and all of that stuff. So if I take this and I multiply by the conjugate, so the conjugate is the opposite of the denominator. So instead of 1 plus cosine, it's going to be 1 minus cosine. So it's only that middle term, that second term, that's changing the value. The reason that we're doing that is because when we end up multiplying this out, you're going to get sine of theta minus sine theta cosine theta. And then that's all over. When I FOIL these out together, you're going to get 1 minus cosine theta plus cosine theta minus cosine squared theta, which gives us, again, that sine theta. And actually, I don't even know why we're going to leave it like this because you're going to see why in a minute. And then this bottom part is 1 minus cosine squared theta. Now, the reason I said, hey, I'm going to leave this sign factored out instead of unfoiling out like I did here is because of this. Well, we know, again, that identity, sine squared theta plus cosine squared theta equals 1. So I can simplify this further because what I can do is I can replace that 1 minus cosine squared with sine squared. So this is sine theta times 1 minus cosine theta all over sine squared theta. So here you've got one sine on top, two sines on the bottom. So cancel that with one of those guys out, and you're left with 1 minus cosine theta over sine. So again, this is just like we're just showing you right now how you can kind of manipulate things. So if I wanted to get sine in the denominator here, what I can do is I can take this and multiply by a well-chosen 1, because this is equivalent to 1, because it's the same thing on top and the bottom, but it's multiplying by that conjugate, okay? Okay, so just bear with me. I know you guys are probably like, why does she like this so much? It's weird. Just bear with me. You'll see why we're doing all this in a little bit. All right, so another technique. Get a common denominator if you're adding two things together that don't have a common one. So it's just like what you guys did back in Math 20. Add two things together. We need to get a common denominator. The common denominator here is going to be 2 times 3, which is 6. So multiply that by 3 on the top and bottom, and multiply that by 2 on the top and bottom. 3, 6 plus 2, 6 gives us that 5, 6. Same exact thing we're going to do here. So this common denominator is going to be 1 minus sine times 1 plus sine. So what this first one is missing is it's missing the 1 plus sine theta. So we're going to multiply the top and bottom by that 1, that equivalent of 1, because that is equivalent to 1, so that's totally legal. It's just like what I did here. And then this guy's missing that 1 minus sine theta on the bottom. Now for me, it's a lot easier for me to remember. I'm going to have to actually FOIL this whole thing out when I put parentheses there. All right, so that gives me 1 plus sine theta on the numerator. Denominator, I'm going to get 1 minus sine theta plus sine theta. So those cancel each other out. So minus sine theta plus sine theta, and then minus sine squared plus 1 minus sine theta on the top. Bottom, again, is that 1 minus sine squared theta. So I'm going to say that part one more time. You can always rewind too if you need to. So you get 1 times 1 is 1, minus sine theta plus sine theta. So that cancels out, and then minus sine squared theta. All right, so now I can actually add these together, because they now finally have a common denominator. Once you have a common denominator, you just add the numerators. So when I add these numerators, you're going to get 1 plus sine plus 1 minus sine. So that leaves me with 2 on the top, because 1 plus 1 is 2. Sine minus sine is gone. On the bottom, we have 1 minus sine squared theta. Now we know how to simplify that. Remember, again, we know this identity. So if I solve, I get that 1 minus sine squared theta is equal to cosine squared theta. And then I can even go further, because I know that cosine is this 1 over. This is the same thing as 2 times 1 over cosine squared theta. Well, what is 1 over cosine theta? Secant. So I can rewrite that as secant squared theta. Okay? So I took something that was super gross and I wrote it into something. It's still, I mean, it's math. Let's be real. It's trig, so it's still not pretty, but it's way simpler. Okay? All right. So now let's talk about other ways we can do this, which is in terms of factoring. So when I look at this and I looked at simplifying it, the first thing that I see is there's a bunch of sines and cosines. So first thing I'm going to see is, again, we use this identity. It's the Pythagorean identity is what it's called, so stinking much. So we can see that sine squared theta is equal to 1 minus cosine squared theta. So I can replace this top part with sine squared theta. The denominator, I can factor a sign out because I have a sign on the top and I have a sign on the bottom. Sorry, and this shouldn't be theta, it should be x. So I get sine of x, I can factor that out. When I factor that out of here, I'm left with a 1. When I factor that out of here, I'm left with a cosine. So that leaves me with, I can cancel out one of these with one of these. So that leaves me with sine of x over 1 plus cosine of x. Now, there's totally another way that we could have done this too. So I'm going to show you guys another way that's going to get us a different answer. And they're all still equivalent. So if I looked at this and I saw the 1 minus cosine squared on the top, so that factors into 1 minus cosine times 1 plus cosine. Oops, I keep on wanting to use those thetas. And then again on the bottom, I can factor that sine out. So when I do that, those cancel each other out, and I'm left with 1 minus cosine of x all over sine of x. So again, there's tons of different ways that you can do these and get to different answers. And we're going to talk about how do you know which one to use and which answer is the one that we're looking for in a little bit, because this is just kind of leading up to trig identities. So one thing will get you one answer, another thing will get you a different answer. So keep that in mind. All right. Rewriting things in terms of sine and cosine. So sometimes you end up getting something like this, and it's hard to see how things will cancel out. So I always tell students the best thing to do is take anything that's not a sine or cosine and make it, because we can write every single function in terms of sine and cosine. So when I look at this, this ends up becoming the cosine of theta over the sine of theta times 1 over the cosine of theta. Well, that's awesome because we've got cosine on bottom, cosine on top. So that leaves me with 1 over the sine of theta, which we know is just cosecant of theta. So who knew? These, when I multiply those together, we get that. Kind of cool.